Welcome. I ended my podcast one slide too soon. All right, so we're going to look at here at exponential decay, and this is continuous exponential decay. The number of milligrams of a drug in a person's system after t hours is given by the function d equals 20e to the negative 0.4 t. All right, it's important that doctors, physicians know how much drug remains in a system. So for instance, if it's an antibiotic, right, they don't want it to go too low, so then the bacteria gain resistance to the antibiotic, and then they become a superbug, and then it's difficult to impossible to treat. Right? Maybe it's diabetes medication. Right? If it's too high, the person's blood sugar will be too low. If it's vice versa, if it's too low, then the person's blood sugar is too high, and neither one of those is good. Right? So a doctor needs to know how quickly a medication goes through a person's system. We want to find the amount of drug after 2 hours. We already have the equation here, so it won't be too difficult to, we won't have to write our equation there. But as a reminder what those different things mean, right? So let's break it down, what the parts of the equation mean. So 20 means that's our starting value, right? So 20 milligrams, because it's in milligrams, of a drug, some medication. And that's our starting value, starting amount. Right, so initial, I don't know if it's an injection or a pill, but it's got 20 milligrams of this particular medication. Right, the negative 0.4 means that it is decreasing, and it tells us that t is in hours. Right, so t is hours. So it means it's decreasing 40% per hour. And it's decreasing continuously 40% per hour. So add this all to your notes. Helps you make sense of these equations. All right, so we want to find the amount of drug after 2 hours, so we'll just replace the t with a 2. All right, so the amount of the medication of the drug is going to be 20e to the negative 0.4 times 2 power. All right, so now we'll just use calculator. All right, so second natural log and negative 0.4 times 2. And then times 20. All right, so there is 8.98, and then everything is more than, so you got 6, 5, 7, 9, they're all greater than 5. So we'll round it to the nearest hundredth. So 8.897, that would round up, because it's 6, 5. All right, so that's the amount of drug, and it was milligrams after 2 hours. All right, so we want to find out what about 5 hours? All right, so now we'll just replace t with 5 and do the same thing. So clear my calculator. And so that would be negative 0.4 times 5. And then times 20, we have 2 point, so it would be 7067, so that's going to round 707 milligrams. What will the amount of the drug be? 1/10 of a milligram, or almost completely gone from the system. To solve this problem, we need to know how to find the inverse of an exponential function. And that's what we're going to use in the next lesson, the inverse of an exponential function, to instead solve for our exponent. Do you remember, what's the inverse of an exponential function? The inverse is a logarithmic function. So we're going to be using logarithms to solve real-world problems. All right, bye for now.